All right, boys and girls, we are back. Yeah, so today let's maybe try to kill all of these to-dos, both the ifs, whens, and maybe the arrays. So we finish all of the features we need, and then we can start thinking on future steps. We may go for optimizations, we may go for like uh, getting rid of this assembly code and just hard coding the X codes and everything, but I don't know. Let's see. Let's see. So to implement ifs, what we need? We need the following. So here I have my dupes. So these are my uh, stack manipulation. These are my conditions. That's fine. Then here we can probably have the if. So the if is going to get some C from the stack. Is going to get the true quote, the false quote, and it's then going to be applied, right? That's basically it. And here we are basically, well, yeah, here we are basically going to get true. Well, we can even define it with C ternary stuff. Otherwise, false. Something like this. I think it's explicit what the behavior we are describing is. So we can even copy apply. I think it's going to be useful, right? We can copy this. What else? What else? Mm, mm, mm. So here we don't actually need. Well, yeah. So we need to get this value, this C, right? And first, yeah, we can move it like to rocks just to check it. So this is going to be R12. This is going to be the dereference of R13. So we need the dereference of R13 minus 8, right? Yeah. So this is basically temp is equal to C, like so. Then we need to test that value, basically. So can do test rocks, something like this, and basically saying this. And this test is basically going to set the flags on the CPU to the correct thingy. So then we can say, is there any, oh, by the way, I found these two websites, and here I have the Intel reference manual. I don't know if this is going to help me or not, because this is a very long PDF, 5,000 pages, and this one, it may be useful or not. But let's go back to our trustworthy page. Here, is there a call if? No, there is no call if. In that case, we need jump, right? Jump if condition is met. So if C is true, so first we need to check tests. So I'm using this one. Where is test? P-test, this one. Logical compare. And so here, it's an end. So it's going to be, yeah. One zero ZF. Okay, we can even swap if that's needed. But so that's basically equivalent to an end. And so here, what the fuck do we want? Jump short if below. This probably. Jump short if not zero. Exactly. Exactly. So yeah, we can implement it like that. So here, jump if not 0, and we want to jump somewhere, right? We can say this is the, so if it's not 0, it's going to jump. This means it's true case, right? So we have here the true case, and then we need to do something with it. Right, exactly. So we can jump there. And if it is 0, and in that case it's the false case, we basically just need to call, and yeah, we just need to call R13. Like so, and that's it, right? Then this is going to fall through, but we need to jump. I think a normal jump is going to be enough. Is there any short jump? Yeah, I can do just a short jump. Okay. And so I can just demark this as a false case, right? Just to be explicit. I don't even need to comment it. So this is a false case. Then we need to jump over this, right? And here we can just call, we can copy this. So we can call, here we are calling the false stuff. And then here we need to call the true stuff. And here to call it, we just do something similar. So we just do that, I think. Oh, this is not R13, this is R12, sorry. Yeah, that is R12. So we do this with the reference R13 and we call that sheet like that. And I guess we just need to finish it. So here we can say if ends, and so here we just jump to if ends. We go to true case or false case, depending on whatever is going on. And here we can just say go to if ends, basically. And I think that's it. So this is the entire if implementation. Let's try it. I may have swapped something around, but let's see. Okay. Damn, I'm getting sick. I can feel it. Okay. So this is if begin and if ends. Let's add it here. Like so. And then this comes before apply. Oh, yeah, I forgot something. Wait a minute. I forgot something. I forgot to clean up the stack. Let's just finish this up. Okay. Something like this. Okay. So I forgot to clean up the stack. And to clean up the stack is actually simple. I can just the other way around. I need to sub. Yeah. So here I can have a label. Something like cases case ends. So both cases will need to clean up the stack. And here we need to clean the following. So 1, 2. Wait, so we need to subtract 24, I think. So we need to subtract 24 because we also need to move. So we need to move the pointer to here, right? But this needs to be copied into R12. So we actually need to move it there. So the stack currently points here. So that's 8, 16, 24. Wait. 8, 16, 24. That's actually 32. Okay. 32 that we need to take away from there. So we need to take why do we need to take 4? We have 3 values, we pop them. We should only need 3, so 1, 2, 3. Oh wait, 1, 2, 3. If we remove, it's going to point there, so yeah, it's actually 24. Okay, but before doing that, we could do this. So we need to move, that's pointing there, -8, -16. So we need to move that into R12, right? Something like this. So yeah, let me just add, okay. And here, this is not going to jump to if end, it's going to jump to case ends. And so this is temp equals C. I don't even know if I need this, but okay. We can test, well, we can check if test works with memory stuff. Let's see. Was lower, still not this one. It works with the memory and the register. Okay, but let's move it to a register. So that's that. This jump is there if it is not equals to 0. So if it is true, we call the second element of the stack. That's correct. And then we remove stuff. Oh, we copy that one. So t is equal to s minus 2, right? Yeah, dereferenced, like so. Then we subtract 3 from s, correct. Here is just called true, correct. Here we go to end, we do call false, that's also correct. I think that's correct implementation. Okay, so that should be everything. So now, fuck, okay. Junk. Oh yeah, I forgot here a new line. I'm starting to be able to read these assembler errors quite easily. It took me nearly a week, but yeah, I'm starting to get an idea how to do it. So if I push like 0, so 0 is false. And then I have my true statement, and my true statement is going to push 42. My false statement is going to push 69. And now my stack is false, and then the 2 different quotes, right? If I do if, okay, it didn't crash, that's so good. And then I do this, oh, it didn't, that's very interesting. So it didn't really do anything. Huh. So I got this, so let me remove that, okay. Here you can say call true, otherwise call false, right? Or we can even use the terminology that we have applied, right? So that's there. This should actually work. Do I feel like debugging this shit after an entire day of work? I do not. So so let me go to the conc. Why is it not working? So we get that. We can get that. So here the expected behavior was so false 69. Expected 69. And we can try to provide more context. I know I'll need to delete shit from here. Yeah, for sure. So let's just delete a bunch of stuff that is not really needed. Okay, and then here that's more or less interesting. That's also more or less relevant. But then probably this shit does not need to be here at all. Yeah, can get rid of all of this. And now the context is small enough. Cool. Let's see what it says. Fuck. Yeah, so let me delete chats. Can I delete? Maybe so it doesn't like me to have so many chats. I don't know. It should be within, but okay. So they have a bug in their site, apparently. Let's try again, but remove some stuff. I don't know, something like this. What else can I remove? Probably this stuff. Yep. I see. Okay, so this shit is not working. Let's try a different model. I don't think we have used that one before. So it's really the message that it doesn't like. Let's remove a bunch of stuff. Like maybe apply for this is not needed. Yeah. Do you like it now? Okay, so it knows it's okay. Uh, uh. The function call logic seems reversed. Typically, you'd want to call the function based on the condition. Yeah, but no, not really. My stack will have cons true quotes, false quotes. So false is at the top. Okay, so that's the first thing it went wrong. Oh, it's moving it into registers. Okay. But what? Well, that didn't really. Let's load this and let's wait. JZ false. Oh, that's the configuration. Give it a whatever. It still gave me the wrong. Like these small clankers are really stupid, aren't they? Let's just try GPT-5 Mini just to have a comparison. But basically, it told me to do JZ instead of J and Z. But that again, yeah, sure. Sure. Yeah. We can try it, I guess. I don't feel like thinking right now. So if I get 0 and then 42 and then 69 and then if we just got 0, right? So it seems that if is consuming just the top 2. Wait, maybe I'm copying the wrong value here. If I copy... So it seems that I'm copying this condition. Huh. Doesn't it? Because, like, what happens if I don't do this? So let me just copy it, like so. Yeah. So okay. So I see. So my stack shuffling is actually incorrect. So thinking is actually faster than clankers, by the way, guys. My brain is still faster than a clanker. So this one, I'm copying the wrong value. It should be -8 or something. So, oh yeah, it's -8 because, no, wait. I'm pointing here. If I get, wait a minute. Is it really -8 or, man, I'm not being able to make. Okay, so -8 is not correct because -8 is copying that. Then minus 16 copy that. Oh yeah, wait. Because that pushed something. Oh wait, yeah. I cannot do this shit. I cannot do this shit like this because I first need to get rid of this. So if needs to behave like for, because I need to keep like the state in memory. Because if my function call pushes extra stuff onto the stack, like a bunch of other things, this is not going to work. So I first need to, yeah, let's do it then. I need to do the following. I can, okay, so I can push that. Then, so this is going to push. Well, I don't need it. Yeah, I don't need to push that. I can move that into a temporary register. That's okay. But I'll need to push the true and the false. Right? Maybe not. Yeah, I don't actually need to push the true or the false. I just need... Huh, that's a very interesting thing. I just need to do this stuff before. But I know for sure that sub q is going to fuck up the test. So I need okay, so I need to do this. I need to use my brain first. Okay, so if I move, this is going to fuck up that. Okay. Yeah, so I need to save that as well. Okay, I see. So let's use the following registers. We need an extra register, I think. Let's use R14 as another temporary register, so it's going to be temp2 or something. Temp A, or I don't know, call it temp1. So we need to move sheet into temp1. But how do I do it here? Oh yeah, because here I pushed stuff. Let me see. So yeah, I pushed stuff. Oh, here I compare it. Oh yeah, but I go to that value in RSP. I see. And Rax is that below. Let me think. Exactly how do I want to do this? If I push that, I push the other one. I think, but it's like more efficient to do it this way, I think. Yeah, it's a lot more efficient. So if I push this into temporary register 1, and that's, yeah, but the only thing I need to push into temporary register. No, I need to keep it track on the stack, I think. I'm forced to do it. Yeah, I'm literally forced. Yeah. So this S points at here currently, -8 points at here. I need -16, right? So I need -16, and I need to push this value. Okay. So let's push it onto the stack. So this is going to be push this. Okay. Then, do I need to save anything else? I could move. So false is going to be inside R12. I could move true into a register. Why not? Why not? Well, but here I'm calling. Yeah, I don't really need to, so let's just do that. But here, yeah, fuck. Yeah, it's better to move it into a register because here I'm subtracting, then I need to do all of the shifts. So okay, so let's move. Where is it? This one. Let's copy it. Okay, we can move that one into R 14, right? Because this is temp 1. And this one is equal to the true quotes, like this. Then the false quote is already in R12. That's fine. And so we can literally subtract 24 from here. But is it? Oh yeah, because then I can at the end. Okay, yeah, it makes sense. Wait, but this doesn't make any sense, right? Because if I do this, once this executed, I don't want to have any of this in the stack. So we are forced to even have another register, right? I think so. Let's have like, so this is temp 1, temp 2, temp 3. I know, something like this. Because here, we need to extract whatever is in R12 into one of the temporaries. So let's say, okay, let's say move Q R12 into racks to our first temporary, right? So this is temp 1 is equal to the false quotes, all right? Then this one is moving the true quote into temp 2, okay. Then we need to move C into a register, to in this case temp 3, because this operation is going to fuck up the flag, so we need to do it before. We are literally forced to do it before, like so. In this case, temp 3 is equal to the condition, right? Then we get rid of this. So this points at there. This points there. We need to move 1, so 8, 16, 24. Wait a minute. So this, oh, this is S, 8, 16. Yeah, we need to move 16 into R12. All right, before doing this. So that, like this, and this is minus 16. So this is basically T is equal to S minus 2, right? And then we can finally subtract 3 items from the stack, correct? Yeah, and we played R13. So when we do these sheets, and in this case, the C is going to be in temp 3, which is R14. So we can just use R14 here, like this. Exactly. We do this test. This is not only to fuck up the flags. This one is going to execute, and we need to execute false, and false is stored in racks. Okay, so let's use racks. Then we do case ends. True is stored in R14, apparently. Yeah, R14 directly. It's fine. And then we no longer need case end. So to clean up the if, because everything was already pre-cleaned up before. Exactly. here I do subqueues. Yeah, so my for loop actually works because I subtract stuff from the stack before executing. So here I don't need these. I can just call that like this, and this should be the entire if implementation, I believe. But let's try it. So false. If it is false, I don't know. Let me print 6. If it is true, I can put 7. Oh yeah, the order runs. If it is true, 6, otherwise 7. If I do this and I print a stack, I get a segmentation fault core dumped. Okay. But why exactly do you... Okay, so if I do 0, 6, 7, currently have this stack. If I do an if, oh sorry, if, yeah, I got a segmentation fault when I do the if. And I think this is actually jump if not 0, by the way. I think the clunker was wrong. So let's see. Why am I getting segmentation faults? I need to copy. Well, I can copy a better example. Well, this one is actually good. Wrong registered address. You set R14. Did I? Oh, fuck, yeah, I forgot to copy. So this is R15. Okay. Yeah, the clinker was actually able to pick it up. So this is R15. And here my C got updated. So this is R15. Yeah, that's correct. Okay. So if I do this, and then I try to do the same thing, so 6, 7, like this, and then I do if, it didn't blow up. If I print a stack, I got 7. So yeah, it's correct. So the if is working apparently. And if I do something similar, so 1, and then I do that, and I print a stack, I got 6. So the codes are being executed properly. Cool, cool. Yeah, that's basically the entire if implementation. We don't need to do anything else. And here we basically we in the, everything that has like conditions and branching and everything like that needs to clean up the stack before executing or calling the quote or closure, because the stack needs to be cleaned. It needs to be like properly cleaned up for the closure to execute. And we do the same here. Yeah, we do the same here. So it's actually correct. All right. So let's implement the when, I believe. So this one is done. It is working. Let's implement when words. It's gonna be similar, I think. Let's not get hard. So in this case, the only difference is that we do not have a false range. We just say when. So C is true, apply true, otherwise no op. Right, it's just a no op. All right, we can change this to when, right? And in this case, this, so R12, we move it to racks. So this is going to be the true. Then we can put R13 on R14, but this is going to be C. Well, we can put it in R15 just to, yeah, just to be equal and have minor changes. So then we can T is equal to that minus 8. So we just need to subtract 8 from here, and we need to subtract 8 from here. So this is going to be minus 2, minus 1. Then we test C, same stuff. Then here, jump if not 0. We could, so jump if not 0, could you do jump if 0? Yeah, jump if 0 to when ends. And if it is not 0, so if it is true, we just do that, right? Go to when ends if false, right? If 0, something like this. I think it's correct. So if it is 0, we go to end, we don't care. If it is not 0, if it is true, we just call whatever code we add. And that's the entire implementation. All right, so let's just add a little bit of boilerplate we need. Like this. When. And what we need here, where is my if? Oh, we are starting to get a lot of words. Fuck. Wait, when ends when. So let's test it. We can do something similar. So 1 6 when we got the segmentation fault. Fuck. Okay, so this is when, this is correct. Did I fuck up somewhere? Okay, when. So the true quote is going to be here, that's correct. True quote to temp 1, which is rux. Then we move the second element, the reference, to temp 3, which is R15, which is correct. Then we subtract 1 from S, which puts it there. Oh no, we move this one. Is it true? So yeah, this is S, this is, yeah, it is true, to R12, which is the top of the stack. Then we subtract to get there. Okay. From R13, it seems to be fine. It seems to be fine. R14. Oh yeah, it's not R14, it's rux. Okay, that was the bug. So 1 6 when we get 6, then 0 7 when we get nothing. As you can see, this is actually working. Cool. And it consumed everything, you see? So it didn't execute anything, but it consumed the stack, which is cool. Very cool, very cool. Right, so let me terminate this. Okay, and this is the entire code. Okay. So we have conditions now, if and when. We can fine tune them later, but I think they are working pretty reasonably well. Now let's work on arrays. To implement arrays is actually, I thought a little bit about it, and I think we can do something very much simple. Where do I have it? Okay. So we have a bumpy, which is bump allocator for executable memory. We can have something similar for data. So we can have, let me change this bump allocator for executable memory. And we can have a bump allocator for data or read-write memory. Actually, yeah. Read-write memory. What can I call this? I can call bump v for data, I guess. Yeah. We can later have actually like garbage collection in a very simple way, because since everything is managed by the stack, we know more or less when the pointer is going to be deallocated when we have type checker, right? But yeah, let's not try to do too much now. So for bump v, I think I only need like append, to be honest. So let's try to do it. So this is data, yeah, data appends and I'm just going to append like one item at a time, right? Yeah. So I can have just int 64 and this is, we can call it item, I don't know, element, I guess. Can append one element at a time. Then that's bump D, right? Then we can even say that bump D is because am I going to, oh no, we can actually have like strings in the future, so this needs to be a byte array. Fuck, okay. So it needs to be a byte array. So in this case, let's say append I64. We are only going to support integers for now. Then here we can do memcopy, I guess. When we can copy elements size of int64 like this. And here we are going to do it like this. Yeah. You can even extract this to size just to be slightly prettier and do that. Sure. So data appends. And how are we going to do this? Well, we are going to do it exactly how I have it here. So we are going to first append the mock element, which is going to be the count of the array. And then we're going to start appending elements, right? And then when we get to this like thing, we can just patch the mock size basically. And then when we have a garbage collection, we can actually force every single array to be dynamic array and have size, or at least the capacity, be a power of 2. Right? But for now, let's keep only static arrays. So I think we will need like a very, yeah, so here we will not need this because we cannot have quotes inside. Am I going to support arrays inside arrays? I don't think so, because an array inside of an array is just a flat array with a specific shape. Yeah, so I think we can literally just support flat arrays always, and just if we want like multi-dimensional arrays, just have some kind of data structure that shapes the flat array like in a specific way. So we can just have this and have like array start like so, and then we can have the following. I think a boolean is enough, and we can say array mode or something, array compilation mode. Yeah, why not? Like so. And then we just need to add a few words, 2 words exactly. Let's add them here. We can copy everything up to there. So here, if we get like the first, this is basically going to signify that the array is starting to be compiled. So we just need to do the following. So array compilation mode equals true. Then we need to say array start. Well, I can even say there. Array start is equal to data dot append there, and we append the mock size, which is 0 for now. Oh, and we need to keep track of the size of the array. Yeah. Or I could increment it always every time. Well, but we can increment it in a single operation, I guess. Where is it? It's somewhere here, right? And then, okay, so we also need a patch. Data patch I64. And we can patch, yeah, we can patch it like this. So we can assume that there, this doesn't need to return anything. Can patch a pointer and there. Size, and we don't need to do that. We don't need to do that. We can inline this in that case, and this can be all removed. So this is the patch. Okay. So this should start the array. We just append a empty or at the start it is an empty array, right? So 0 size, and this terminates the array. So, hey, by the way, we can add a check just to make sure that we do not start compiling an array if we are already compiling an array. So in this case is array compilation mode. If array compilation mode is that used that what's the error inside array compilation mode. Cool. Then if that's not true, we can keep going. And the same thing, like it happens there, right? We can just say if it's not in array compilation mode, we can say inside of array compilation mode and outside of array compilation mode. Cool. Now, if we get into here, we just need to mark the array compilation mode as false. This doesn't care, we just need to apply it, right? So we need to say data patch i64 in array start, and we need to the element, and for this element we just need to say array count or something like that, or array size in this case because it is a static array. So we can say size t array size. We can initialize it with 0. And every time we start an array, we need to also reset it. So array size equals 0, like so. And then we just patch it with array size, like this. Now, the only element we are going to support currently in the array is going to be numbers. We are not going to support anything else. So if we got here, we know that we didn't get a number as a word, right? So we can say if array compilation mode is true, and we got here, we can literally just say error write, or we can say only numbers are supported inside arrays, right? And you can say continue. Or if you need to say got something like this, yeah, let's say something like this. Cool. So if I, okay, so this one is const, I cannot have it as const. Okay, so that was the only complaint. So if I do that and then that, I get the segmentation false. Why? Oh yeah, because my memory is never, I forgot to allocate my memory. That is 100% correct. So bump v starts, bam, bam, bam. Here is going to be bump p. I gonna just use prot reads and writes, right? Then map private is the same, map failed, everything is the same. So here I just need to unmap that as well. And this is going to be bump d start. And here I can even say, yeah, I can even print the data segment. And here I just literally just need to replace that by that. Void bump t. Do I want to print my data segment as 64-bit integers, or, well, I guess I can print them as hexadecimal. Cool. So now let's see if I can create an empty array. Only numbers. Oh fuck. Yeah. Yes, that is actually correct. That is actually correct. Because here I also need to check this. So I can be closing out the array, yeah, sure. If ends it's not that, only numbers and are supported inside the array. Or I can even say only that and numbers are supported in array compilation. Inside, yeah, inside arrays. Sure. I can tune the errors when I put this into production ready code. So if I do that, that worked. Okay, but this is not fully implemented because my array also needs to push the address of the array into the stack, right? So if I get here, this needs to push array start. I need to say lit array start, okay? And this is just for REPL mode. So if I do this, I push an empty array and I print a stack. Okay, now I have the pointer to that specific array, that place in memory where the array is. Cool. Let me close it. Okay. And my data is empty, as you were able to see. But if I am inside some compilation mode, some like word compilation or inside a quote or something, I need to append code for that. So here, how do I do it? If I am in word compilation mode, or quotes depth is greater than 0. Is that what I want? Yeah, because everything else also uses that. So we can do it like that. So yeah, here we have the condition, else we just use the immediate version. And to do that, how do I, well, I need to push a literal, right? Let me see. It's just this, basically, right? Just this. So lit begin here. Yeah, I need the primitive now. Okay. I also push it. Oh yeah, I also push it there. Yeah, but here I do special stuff that I don't need in this case. Cool. So here I need to push some int 64t i64, which is literally going to be array start. Right, so all right. So if I'm in the REPL mode, I just instantly push that. It's fine. If I am compiling a word or compiling a quote or something, I just generate a code that is going to push that address into the correct stuff. Okay. So, and this is actually going to make it harder to have a garbage collector, to be honest. Huh. Yeah. So maybe in the future it would actually make sense to generate codes that pushes the array into the data segment or something instead of just pushing the, yeah, but we will, that's a very like future question. I don't even know if I'm going to have a garbage collector, so it's okay. So if I do this, and this is in immediate mode, you can see this is the now the array, the pointer to the empty array. But if I do it inside the quotes, now something like this, add apply, and then I print the stack. You can see, where is it? Oh, this pushed. Oh fuck, yeah, I'm forgetting something. Well, am I? Wait. So this 12.68907549504, it's the same address, isn't it? I think it is. We can even use our own language to check it. So if I put this and then I do equals and then I print a stack, yes, they are equal. Okay. You see, our language is even being useful now. So that means I fuck up something. Why? So this does that, Don't I? Yeah, I bump. Oh, I'm bump T. I need to bump V. Okay. Bump T, not bump E. So let's retry that. So empty array, we got that. Perfect. We create the quotes with an empty array inside. We apply that quote and we print a stack. We get, yeah, eight bytes separate. So that's the difference. So here we get, yeah, we get two arrays with 0 size. So this data segment now contains the size of two empty arrays. Cool. Now let's try to create arrays, but yeah, I still need to patch these because this is actually not correct. I just remembered. So if we are in word compilation mode, we do that, but if we are in array compilation modes, let me put it even here. So this is more like close to each other. If we are in array compilation mode, we need to do data append i64, and we just put that there, right? And this one actually can come here because it's specific to that. Cool. It is complaining about something that is not an error. Okay, so if I do something like 1, 2, 3, 4, when I close, okay, if I print that, we just have the address, and if I get here, we get 1, 2, 3, 4. As you can see, we got all the elements. Okay. Now, if I create a quote, for example, with the same stuff, like so, here I'm going to have the address of the quote. This is the address of the quote, not the address of the array. I first need to apply the quote, right? And this gave me a different address, as you can see. So this address is slightly different. And this is the address of the array now. I cannot do anything with it right now, but I can terminate my program and I can see that now my code section has things in it. This sheet is probably, so 49 BC, 1, 2, 3, 4, 5, 6, 7, 8 is probably this one. So this is the address or something. Yeah, that's probably the address of the, or maybe this one. One of those. So this is, one of those is the address of the data pointer. And then, oh, but here I can already see that. Oh yeah, fuck, I forgot to increment array size. We can increment it here, or we could increment it right away. Because yeah, maybe in the future we're going to have more stuffs that are not digits in the side array. So if I do now 1, 2, 3, 4, 5, 6, I don't know, 6 elements, and I finish, the array size is 7. Why is it? Oh yeah, fuck. I actually need to increment it there. Yeah, it needs to be in here. Okay. Because it was triggering like an extra stuff on the last one in the closing thing. Let's try again. 1, 2, 3, 4, 5, 6. It should be 6 now. Yeah, it is 6. So the array size 6. These are all of the elements of the array in 64 bits, of course. And then if I do the same for quotes, so if I do this, I copy that, like so. I don't even need to apply the quotes, to be honest. Yeah, I don't need to apply the quotes. I can terminate this, and this array is already going to be compiled into the data segments correctly, right? And this is the pointer to the quote. So it's working. It is working. This was a very productive video. Was less than 1 hour, and we implemented if, when, and static arrays. Let me try to think. Maybe we can implement some operations for the arrays. Yeah, why not? So we can say we can have the size or the length. Yeah, so this is implemented. That's good. Let's implement the length word or something, which takes the length of an object in the data segment, in the Yeah, in the data segment. So where are we going to implement it? So object manipulation things can go here. So let's say we have an array or an object, right? Yeah, we can say, well, let's say array for now. Let's say array for now. The this word is going to give me the length of the array, right? So that's basically the operation we are implementing. And so this is going to be an array pointer, by the way. So every single thing in this language is going to be always 64 bits, right? So if I have something that is bigger than 64 bits, it's going to be a pointer. Anything below 64 bits is going to be a word. Anything above is going to be a pointer. So it's easier to manage memory, and if we want to have like garbage collectors, we can have them. So here we basically want to do the following. So this is going to be the pointer. We know that, yeah, so this is actually quite simple. This is actually quite simple. We just need to do move q. We need to move into R12. Yeah, so we need to move into R12 whatever value is in the R12 memory address, or the value pointed by R12. That's it. So this is the length implementation. Yeah, exactly. So we just need to add the boilerplate. Let's see. The length. We can put it there. The length. This shouldn't really be a primitive word because this is not callable by the user, to be honest. So yeah, maybe we can change that. This is length, and here we just need to change this to length. And this does not need patching. Okay. So if now I create an array like 1, 2, 3, right, and I say the length of the array, fuck, okay, so it didn't work. Is it because I'm using exactly the same register for two things? So I'm writing and reading from the register? It shouldn't really matter, does it? Actually, I don't know if this matters or not. Let's ask the clanker. So thanks, just to so he knows that this is fixed. Why is this sec folder? Yeah, so that's the fuck. Okay, okay. So if it's not a valid address or not properly aligned at that time. Oh, so it needs to be aligned. Let's first confirm that the pointer is correct. So one way to do that is actually to just print it when we initialize it. Oh wait, I think I know why this is fucked. Did I print? Oh no, I'm printing the correct thing. Yeah, I'm pushing the correct address. Okay, so that's actually good. Let's go here in that case. And let's print this actually as an integer because that's what we are outputting there. And let's just say exactly the same casting, and just to bump the start. And if I do something like this and I print the stack, so Let's check if these two values are the same. It should be the same. Right, equal. Yeah, there it's 1, so they are the same. So why is this fucked? Is it maybe it's because I'm using the same register to read and write, so maybe that's not allowed. I don't know. Let's try to use rux in that case. So move whatever is in there to rux, and then move whatever is in rux to R12. So let's try that. If I do this and then length, no, it's still segfaulted. Why are you segfaulting? That's strange. Maybe it's something like with the protection that I'm using, but I allowed it to be read, right? Prot reads. So the address is correct. Checked that the address correct. That has nothing to do. Bumpty is read write only. If your JIT writes code into bumped, no, it's okay. This is already like doing weird shit. Let me go to the good clanker. I just need to open this. Let me just open not this one, that one. So let me go to the boot clanker so it's faster. So length, the word len is sec faulting finds y. And I can also give the example that we had. Something like this. Okay. And while it is working on that, oh, but there isn't really anything I can think of, to be honest. Like, it's pretty standard. So these dereferences are 12, which should be a valid. Okay, the clanker actually answered because I'm using the first version now. If your main loop, when a word is identified as a primitive, sure. Lang begin label in your primitives function. That shouldn't. Oh, it's missing. Ah, fuck yeah, it's missing a right. Okay. So it was actually able to pick it up. Okay, one more good thing for this performant clanker that the other clanker was not able to figure out. Or maybe it was. I was just stupid and I didn't want to read it. Did he talk about... well, he talks about RSP and whatever. I think it's just... yeah, whatever. So let's test it now. If I do this, then the length, I get 1. Okay, if I do 2, 3, 4, 5, 6, and then the length, and I do this, I get 5, which is correct. Cool, and here I have both arrays. So this array here, and this is another array here. Okay, so let me try to do the same thing, but without using rux. Just doing a single instruction to get the length. 1, 2, 3, 4, 5. Length print stack. This should give me 5. Correct, it's working. Cool. If I do the same inside the quote, so 1, 2, 3, 4, 5, and I just do, I don't know, dupe, right? Dupe length swap, so I get the pointer on top, and then I do apply, and then another length, and I print a stack. I should have 2 5s on top of the stack. Correct. Okay. Yeah, I mean, this is already quite high level code, I would say. For such a simple language, so if we get this example, this is already quite high level code. We can even test it inside words just to make sure. Length example, bam, like so. Or can we put select there and then print a stack afterwards? Oh fuck, I need to call length example and then print a stack. Okay, so we can have this example, so I can show you better. So basically I'm defining the words, length example, then I'm calling the word, and then I'm printing the stack. So that's what I'm doing here. I also get 5, 5. So everything is behaving as expected, 100% as expected. Cool. So we have arrays, we have quotes, we have a bunch of very interesting words, we have conditions, we have ifs, whens, and all of that. Do I have examples for ifs and whens? I do not. So let me also have an example here. So 1, 1, 6, when, and then I can also have 1, 6, 7, if, right? And I can also have an example for zeros, right? So that's basically it. I can print the stack in every single one of them. Cool. I mean, is there anything else I want to work on now? I don't think so, because everything else is going to require quite a lot of effort. So let's try to define the next steps, because what we define now will actually impact quite a lot the next videos, right? Because the language is already good, it's already working. We have conditions, we have loops, we have everything. Like there is nothing much else we can do about it. Everything else is going to be like super boilerplate things. So let's create a readme or something, a text. What do we want? So my initial goal was to have types, right? Do I want to have types right now, or do I want to work with my language for a slightly longer, maybe implement a small project in it, and try to figure out exactly if it is good, if it has good ergonomics, good syntax, good semantics. It could be an option. I could also start defining a small kernel language, and this kernel language would basically just be the bootstrap for all the standard lib. So bootstrap for the standard lib with all the standard words, right? So that's one option. And in this case, like, do we want to detach our language from C? So do we want to just implement it directly in machine code? If so, we would probably need a few words. We probably need system call. We can call it syscall. We would probably need syscall 3. So for the 3 arguments version. What else? I can say if we want to detach it from C, and if we implement it, we need syscall 3. We'd probably need we probably need quotes, I guess. Well, yeah, we need quotes because we need quotes for if conditions. So yes, we will need quotes. Would we need arrays? I don't think we would need arrays in the first version, to be honest. So no arrays. We would probably want to have logic. Yeah, logic stuff. You can say conditions. Right. What else? We would probably need loops and some basic stack manipulation words, so we can call it combinators. Right. So basic combinators, basic loops, and well, we can have all of the conditions because they're not that many. So this is one path, but if we detach it from C and we go purely 100% low level, then it's going to be harder to implement a type system, right? We need to have that into account. We could also move with all of the optimizations I described here. That's also an option, but I don't think it's going to be worth it right now, because to measure the optimization impact, we need to have some project that actually can be benchmarked, and we don't have anything at all. So yeah, I mean, we could move to like coroutines, like, and have the language be support multitasks like concurrently. That's also an option, and we could even like split all of the tasks across logical threads, like system threads, and have that abstracted away from the user. That's also an interesting thing. So we have types. We have small projects in the language, right? So type system, right? We have small project in the language. We have kernel language where we are able to bootstrap a standard and else. I feel like we would only be able to fully know what to do here once we at least have done that, right? I don't feel like this is strictly necessary, but it will be painful to do this without this. So this could be prioritized. Then optimizations like this is like the bottom optimizations. Like this is the least priority, right? Threads are cool. Threads are cool. We could even have them here, threads, right, or something like this. We can call them green threads, or maybe like we can keep it like that. Is there anything else relevant? And I mean, we would only be able to define the standard once we started using it. So yeah, maybe we are just going to implement a very thin type system next video. So we implemented a very thin type system on top of what we have, and we don't care about this, because this is going to be thrown to trash, because once we start implementing the language in itself and with each C, we will no longer need this shit. And yeah, I mean, that's it. Oh, one thing that is may actually be even important is FFI with C. Like maybe use lib FFI. That's one option, right? So we don't need to worry about all of the APIs and everything. But if we use that, does it make sense to do this, like detach ourselves from C? Maybe it does not make sense, right? Maybe it doesn't. So there's a lot of things that we need to consider. But yeah, I think that the priority will be this one. So we will start working on type system next video, right? And after the type system, and we are like relatively confident in this very basic implementation, we implement some project in it, like I don't know, maybe a small game or something else. I don't know. With this small project, we can test it, understand what the fuck is going on, and understand like what is needed or not. And from there, we can take like more conclusions, I would say. So let's keep it like this. And by the way, this code can be fully deleted, delete permanently. We don't need it anymore. And this is it. Oh, by the way, one of the goals, I don't know if I described this before. So I want this to be a simple single pass compiler, but to allow for basic optimizations, basic or with optimizations that can be supported in a single pass compiler, by a single pass compiler, basically. I want this language to feel modern, right? Like so, and with this I actually mean like quotes and maybe garbage collector, right? What else? Modern syntax or something like modern syntax and semantics. Like I want to have a good standard lib, right? What else? I want the implementation to be small in foot. Yeah, the kernel, I bootstrap needs to be small. Ideally, less than, I don't know, less than 3,000. I'd say 3,000 lines of C or something. What else? What else? I think these are the main goals, right? Oh yeah, fast. Okay, it needs to be fast. So these optimizations need to be able to like achieve like maybe 70%, maybe 70% plus of the C speed of C or something like this. Be able to compete with other interpreted languages. So by this I'm comparing myself languages. Okay, I'm comparing myself to Lua. Of course, we will be faster than Python, etc. Right? Because that's not even a challenge. Okay. Because Python does not compile to machine code. And even if it did, their VM is so fucked that it's just so slow. Are there anything? Is there anything else I want? I don't know. Like if you guys have suggestions, you can leave suggestions in the comments. Once I implement the type system, I'll probably open a repo in GitHub so you can start opening PRs if you want to or something. But yeah, I think we are in a good state. We are in a good state. So we are already like slightly better than Forst, I would say, because of the modern syntax and the ability to have codes and everything, and the ability to have arrays, and you don't need to read and write from memory like unprotectedly. You can just do your own thing. Okay, so that's everything for today. So thank you for watching, and I'll see you in the next one.